Okay, let's talk about another component or building block that's really important, and that is the multiplexer, or MUX for short. A common sub-operation that comes up in many applications is having to select from several different inputs, and this type of selection is exactly what a multiplexer can be used for. Now, a multiplexer can be drawn with a box or a rectangle again, but also commonly is drawn as a trapezoid. So say I had 4 inputs, and I wanted to select one of these to drive or be connected to the output F. I'm going to use 2 other inputs, or select lines, to select the corresponding input, A0, A1, A2, or A3, to go to F. In other words, I'm multiplexing the inputs into a single output. So for example, if the select lines are 0, 1, then the value of A1, the binary signal, which could be a 0 or 1, is what will show up on F. So MUXes have many uses, and they actually come up a lot in many different types of designs. An example of some of them include selection, an N-to-1 switch, parallel to serial conversion, or implementing a Boolean function. The label for this MUX, we could call this a 4-to-1 MUX. Now let's take a look at how we would build a multiplexer. So for this 4-to-1 MUX, the Boolean expression that represents the output, F, would look something like this. If S1, S0 are select lines, are 0, 0, then A0, whether that's a 0 or 1, will be my output. And I can do the same thing for the next input. So A1 will be selected if S1 and S0 are 0, 1. Okay, so the circuit diagram then for this so if I look at the Boolean expression, I see that I have all of the minterms of the 2 variables S1 and S0. So I'm going to go ahead and reuse some logic here that we've already built, specifically a decoder, because a decoder can also act essentially as our minterm generator. So I'll use a 2-to-4 decoder. And now I just need 4 product terms, ANDing each of those minterms with one of the inputs from the MUX, and then ORing these all together. So when S1 and S0 are both zeros, then the 0 output of my 2-to-4 decoder would be a 1, and I would like to select A0. And if my select lines are 0, 1, the 1 output of the decoder is a 1. And that's my 4-to-1 MUX. So to recap, a MUX takes multiple inputs and then selects by setting the select lines, one of the inputs that are connected to the output. So if I have n inputs into my MUX, I need at least log n select lines. We've also seen now how to build a decoder. And the standard decoder took some inputs which represent the address of the address, that's a 1, and all other outputs are 1. So for the standard decoder, only one of these outputs will be a 1 at any given time. Now these two components have many uses, and we'll see that they come up many times in different types of designs. Sometimes also we might see related blocks. So with the decoder, I could also have an encoder block, which essentially does the opposite of the decoder, takes multiple inputs, where only one of these is exactly 1, and encodes the address of the input line on the output. And the demux which takes an input and based on the select lines connects the input to that corresponding output.